Hello everyone, my name is Dayoni from 1IPAA and today we're gonna learn about 3 laws of motion by Sir Isaac Newton. First law of motion or law of inertia. Inertia refers to the tendency of a body to remain at rest or to continue moving. The other definition is the potential of a body to resist from any sudden change in motion. The first law of motion states that a body at rest will remain at rest and a body in motion will continue moving at a constant speed in a straight path unless an outside force will act on it. The formula for the first law of motion is sigma f is equal to 0. Example: there are 4 forces acting on a box. They are force A, B, C, and D. Force A is 6 Newton, B is 3 Newton, C is 6 Newton, and D is 3 Newton. To find the total force, we're gonna use the formula sigma F is equal to the total force, or sigma F equal to A plus B plus C plus D. Every force that are going up or right is positive, and every force that are going down or left is negative. So sigma F is equal to 6 plus 3 plus negative 6 plus negative 3. 6 plus negative 6 is 0, and 3 plus negative 3 is 0. So sigma F is equal to 0. The second law of motion or law of acceleration. It states that acceleration is directly proportional to the net force but inversely proportional to the mass. The formula is sigma F is not equal to 0. Sigma F is equal to mass times acceleration, and acceleration is equal to sigma F over m. Example: what is the force applied on a body with 5 kg of mass and an acceleration of 7 meters per second squared? We're gonna use the second formula, which is sigma F is equal to m times a. The mass is 5 kg times acceleration, which is 7 meters per second squared. 5 times 7 is 35 Newton. So sigma F is 35 Newton. The third law of motion or law of interaction. It states that for every action, there is equal but opposite reaction. The formula is F action is equal to negative F reaction. For example, a 3 kg box rests on the table. What is the normal force acting on it? So first we're gonna draw the diagram. This is the box that rests on the table. What is the normal force? We're gonna use the formula F action equal to negative F reaction, which is N is equal to negative weight. N is equal to negative 3 times negative 9.8. N is equal to 29 Newton. Example number 1. The diagram below shows as a particle act on by a set of force. Given that the particle is at rest, find the value of P and Q. So here is the diagram. First, we're gonna solve for the x-axis. Pn is equal to 50 Newton. Cancelling Newton on both sides, so P is equal to 50. Now we're gonna solve for the y-axis. 5Q is equal to Q plus 10 plus 3P. P is 15 Newton, as we solved before. So 5Q is equal to Q plus 10 plus 3 times 50. 5Q minus Q is equal to 150 plus 10, equal to 160. 5q minus q is 4q is equal to 160. So q is 160 divided by 4, which is 40. Example number 2. The diagram below is said to be accelerating at 2 meters per second squared. Find the magnitudes of the unknown force x and y. So here is the diagram. First we're gonna solve for the x-axis by using sigma f is equal to mass times acceleration. Sigma f is x minus 4 is equal to 2, which is the mass 2 kilograms, times acceleration 2 meters per second squared. 2 times 2 is 4. We move negative 4 to the right side, so x is equal to 4 plus 4. X is equal to 8 Newton. Next, we're gonna solve for the y-axis. Y is equal to 2g or 2 gravity. Y is equal to 2 times 9.8, which is the gravity. Y is equal to 19.6 Newton. For the y-axis, we don't use sigma f is equal to mass times acceleration because there's no acceleration in the y-axis. Example number 3. A truck engine of mass 5,000 kg pulls a trailer of mass 1,000 kg along a level track at an acceleration of 0.100 meter per second squared. The frictions are 10 Newton per 1,000 kg for truck engine and 5 Newton per 1,000 kg for the trailer. First, draw a free body diagram for the truck engine and for the trailer. So here is the truck engine and here is the trailer. The mass of the truck engine is 5,000 kg and the mass of the trailer is 1,000 kg. The acceleration is 0.100 meter per second squared going to the right. There are connecting tow bar between the truck and its trailer, which means there is tension force between them. The frictions are 10 Newton per 1,000 kg for truck engine and 5 Newton per 1,000 kg for the trailer. So the friction of the truck is Fe or F engine and the friction for the trailer is Ft or friction trailer. Last, there is forward thrust exerted by the engine. Now we are going to calculate the tension in the connecting tow bar between the truck and its trailer. So we are going to find P. P plus negative Ft is equal to Mp times A. M is 1,000 kg and A is 0.100 meter per second squared, but we don't know what is Ft. Ft is 5 Newton per 1,000 kg for the trailer. The mass of the trailer is 1,000 kg, so the friction of the trailer is 5 Newton. P minus 5 is equal to 1,000 times 0.100. P minus 5 is equal to 100, so T is equal to 105 Newton. Next, calculate the forward thrust exerted by the engine. So we are going to find Fe. Fe plus negative T plus negative Fe is equal to Me times A. We know the M and A. We also know the T, but we don't know what is the Fe. The friction are 10 Newton per 1,000 kg for truck engine. The mass of the truck engine is 5,000 kg. So, to find the friction, 10 Newton times 5. So, the friction of the truck engine is 50 Newton. So, Fe minus 105 minus 50 is equal to 5,000 times 0.100. Fe is equal to 655 Newton. Now we're gonna learn about coefficient of kinetic friction. Friction is a force that opposes motion. There are two classifications of friction. The first is friction between two solid bodies, and the second is fluid friction. A. Friction between two solid bodies. Static friction. Static friction is a friction that present in solid bodies at rest. Sliding friction is a friction that present when one solid slides over another. The last is rolling friction, is a friction present when one solid rolls over another. B. Fluid friction. The definition of fluid friction is friction present in liquid and gases. Kinetic friction or sliding friction, F or Fx. F is equal to mu times N, or mu is equal to F over N. F is kinetic friction, mu is coefficient of kinetic friction, and N is normal force. Example number 1. The coefficient of kinetic friction between a block of wood and a horizontal wooden floor is 0.15. If the block has a mass of 0.6 kg, what is the frictional force when the block is made to slide over the floor? So here is the diagram. To find F, we times mu and N, but we don't know what is the N. So first we're gonna find what is N. N is equal to negative weight. N is equal to negative mass times gravity. N is equal to negative 0.6, which is the mass, times gravity, which is negative 9.8. N is equal to 6 Newton. Now we can solve for the F, or frictional force, because we already found the normal force. We can find F by mu times N. Mu is 0.15 and N, normal force, is 6 Newton. 0.15 times 6 is 0.19 Newton. This is the final answer. Example number 2. Find the force of kinetic friction if the block in example 1 is made to slide on a wooden plank. One of those ends is raised at an angle of 30 degrees. So here is the diagram. We know that weight is equal to mass times gravity. We already solved the weight before. The weight is 6 Newton. The question asks, what is the kinetic friction? To find friction, we multiply mu and N, but we don't know what is N. To find N, we are going to use Pythagoras, but we need Fx. So first, we are going to find Fx by using cosine. Cosine alpha is equal to x over r. X over r. X is Fx and r is weight. Alpha is 60 degrees. Cosine 60 is 1 over 2 and weight is 6. So if we move weight to the left side, it will become 1 over 2 times 6 is equal to Fx. So Fx is equal to 3 Newton. Now we are going to find normal force or N. N is equal to square root of weight square minus Fx square. Weight is 6 square. Weight is 6 and Fx is 3 as we solved before. So N is equal to square root of 6 square minus 3 square. 6 square is equal to 36 and 3 square is equal to 9. 36 minus 9 is 25. Square root of 25 is 5 Newton. Now we can solve for the friction. Friction is equal to mu times N. Friction is equal to mu, which is 0.15 times N, 5 Newton. 0.15 times 5 is 0.75 Newton. And that is the final answer. Thanks for watching and see you on the next video.